For 4b, show that eigenvalue of a unitary matrix has absolute 1. As this is a proof, let lambda be the eigenvalue and x be the eigenvector for the unitary matrix U. So, Ux is equal to lambda x. Let's apply conjugate transpose on both sides. Then we'll be getting this equation. As we know, AB transpose is equal to B transpose into A transpose. Applying this formula, we'll get this. As for unitary matrix, U conjugate transpose is equal to U inverse. We'll substitute here. Then we'll get this form. Now, applying conjugate transpose for this equation, we'll get Ux conjugate transpose is equal to lambda x conjugate whole transpose. Equating these two, we'll get this equation number 2. Now, multiplying equation 1 and 2, we'll get this equation. Here, as you can observe, U inverse into U is equal to 1. This value will become 1, such that we will get x conjugate transpose into x is equal to product of eigenvalues into x transpose conjugate into x. As we have same value on both sides, we'll cancel. Then we'll get lambda into lambda transpose equal to 1. That is mod of lambda square equal to 1. This proves the result that eigenvalue of a unitary matrix has absolute value 1. For 5a, find the Laplace transform of given f of t. Here, f of t contains values between different limits. So, generally, Laplace transform of f of t is given by 0 to infinity integration of e power minus st into f of t dt. But here, as they are bounded between limits, we need to consider for t square, lower limit will be 0 and upper limit will be 2 simultaneously for the others. So first, this equation can be written like this. In order to make this integration easier, let's divide this into 3 parts, I1, I2 and I3. First, let's solve I1. I1 is given by this. In order to solve this type of functions, integration of fg dt is equal to f into integration of g dt minus of integration of f dash into integration of g dt. Here f and g are functions of t. Let's substitute these values here. Then we'll find the solution and apply limits 0 and 2. Then I1 value will be this. Similarly for I2 and I3, we'll find the integration values. After finding, L of f of t is given by I1 plus I2 plus I3. So let's substitute I1, I2, I3 values. After simplification, we'll get Laplace transform of f of t as this method. This problem can also be solved using step function. For 5b, given find the Laplace transform of 1 minus of cos t by t. This can be solved using different methods. I'll be using the easiest method. L of t power n f of t is equal to minus 1 power n d of f power n s by ds power n. As we already know this formula, let's take f of t is equal to 1 minus of cos t by t. Send this t to this side. Then we'll be getting t into f of t is equal to 1 minus cos t. Applying Laplace transform on both sides, we'll get L of 1 minus cos t is equal to 1 by s minus s by s square plus 1. As from this formula, we'll get L of t into f of t as minus f dash of s. Then, after simplification, applying integration on both sides, we'll get 1 by 2 log s square plus 1 minus log s. As we already know, log a minus log b equal to log a by b. Using this, we'll get f of s as log root s square plus 1 by s. This is the solution for this problem. For 6a, find Laplace inverse of 2s square minus 4 by s plus 1 into s minus 2 into s minus 3. Here, first we need to solve this into partial fractions. This can be written as a by s plus 1 plus b by s minus 2 plus c by s minus 3. In order to find variable values, take s equal to 2, then we'll get b value as minus 4 by 3, and while s equal to 3, we'll get c value as 7 by 2, and the other way a value will be minus 1 by 6. Substitute these values here, then we'll get this equation. Now apply inverse Laplace on both sides. Then inverse Laplace of 1 by s minus a is equal to e power at. Here, in order to find inverse Laplace of 1 by s plus 1, s plus 1 can be written as s minus of minus 1, that is, so a value will be 1 minus 1, that is equal to e power of minus t. Similarly, we'll find for other inverse Laplace values and we'll be substituting, then we'll get the result as follows. For 6b, using convolution theorem, evaluate inverse Laplace of s square by s square plus a square whole square. So this can be written in this form. Now, as per convolution theorem, L inverse of f bar of s into g bar of s is equal to derivation of 0 to t f of u into g of t minus u du. Now, as per the theorem, we need to find f of t and g of t values in order to substitute. As we know, f bar of s and g bar of s, f of t and g of t can be found using inverse Laplace of f bar of s and g bar of s. So, applying inverse Laplace, s by s square plus a square is equal to cos a t. So, after obtaining f of t and g of t values, substitute here using this formula. We'll get integration of the form cos a into cos b, which is equal to 1 by 2 into cos of a plus b plus cos a minus b. Substitute these values in this formula. Now apply integration and we'll get this result as follows. This is the inverse of s square by s square plus a square whole square.